Hello, through this video we will show you how to design our CAD power line using software PowerPath. In short, we will show you in a real example how to define a road of power line, then how to get power line profile, and how to obtain mechanical calculations and loads along the road. At the end, we will show you a BIM model of our CAD power line. This is an example where we have an input geodetic data, and if we see this in isometric view, you can see that each of these points have x, y, z coordinates. That means that we have accurate positioning points on the basis of which we create the surface. We also have a raster image that serves for a realistic representation of the surface. First step of creating new overhead power lines is defining a surface. Surface is created of irregular networks of triangles. After we create surface, we can show it in many different views. For example, we can set contours in properties, we can turn on or off triangles, etc. For real representation, we can project raster image. In realistic view, we can see how surface looks like. That is a digital model terrain. We will turn off a network of triangles and we will set 2D wireframe view again. Now we are defining our power line. Defining power line is quite simple. You just define the name of your power line. Also, you can define station from where power line starts. Then you can define the name of your supports and tension support model, which is used when defining the road. If we want to have projection of power line on our surface, we can select to drape it on existing surface. We define the power line in this way by placing supports. As you can see, we get the distance between the previous and the next support. When we define our power line, all supports are marked as we defined them in the beginning. We can edit our power line by moving supports, as you can see. The great advantage of this software is when you create 2D model of power line, then you have automatically 3D model of your overhead power line. Now we will add additional supports. You must choose your power line and what types of support you want, suspension or tension. As you can see, we are adding suspension support in some places. And we are also adding tension supports at the end of power line. This is especially important because you can arrange the power line according to your needs. When you zoom your power line, you can see exactly which are the suspension and which are the tension supports. When we have the power line, the next step is to add insulators. We add insulators in that way by choosing on which support we want to add. In this example, we are showing the individual addition of the insulator at the attachment points of the selected support. When we choose attachment point, then we have to choose type of the insulator and insulator data model. Especially important is that this type of insulator can be applied to all tension supports for this attachment point. As you can see, this type of insulator is added on all tension supports. course, there is a possibility to edit Insulator very easily. We have to choose one type of support, for example. In this case, we will choose tension support, and you can add insulators on this support. You can define all insulators that are in front or behind the support for all attachment points and apply them for all tension supports in our power line. We are showing you how to do that. As you can see, we have insulators for all attachment points of chosen type of support. As you can notice, on one attachment point is different type of insulator. So you can additionally add this. We will change this because we want to have the same type of insulator on all tension supports. When the insulators are defined on tension supports, it's also necessary to define insulators on suspension supports. So the process is the same. We have to choose any suspension support, and in the opening window dialog, you choose your type of insulator. You can apply all these insulators for all suspension supports. Once confirmed, you can see that insulators have been added for the suspension supports as well. After we have defined power line, we have added new supports and insulators, and now the next step is to add conductors and ground wire. This is quite simple. We can define the name of the conductor, the model, and from which to which support we want to add our conductor. We can also choose for which attachment point we want to add. This means that phase 1 is connecting to attachment point 1, and as you can see, the conductors are connected to the insulators. Procedure is the same for other phases. We will use the same conductor model and define from first to the last support. Now we have phase 2 connected to attachment point 2. We are going to add phase 3 on attachment point 3, also between the first and the last support as well. As you can see, the conductors are connected to the insulators. The next step is to add ground wire. Principle is the same. We can define the name of ground wire, the model, and from which to which support we want to add. Once confirmed, you have ground wire on all supports. Now we have all elements in 3D as well as in 2D. Getting power line profile is just one click. You can see all phases, you can define the scale, the offset terrain profile, and other additional properties. In additional annotations, we will choose to show the lowest point and the maximum sag of catenary on our profile. We choose where we want to insert the profile. The profile is consisted of supports, conductors, and terrain. Important thing is that we turned on the options to get left and right terrain offsets. The blue and the orange lines show the terrain to the left or right offset side of the alignment. The next step is to get mechanical and load calculations. We have to choose power line for which we want to get calculations. We can choose from which to which support, and do we want all for all phases or only for certain phases. We can define whether we want to save as an Excel file or a Unicode TXT file. In this case, we'll show you how to get the report in Excel file. This report is for tensions and sags. When the file is saved, the report will open automatically. As you can see, we have sags and tensions for all phases. If you want to get lots on supports, you have to choose Support Report. In our case, in the opening window, we will choose for all supports and save in a TXT format. Type the name of the report and save it. The report will open automatically, and in the report you can see the lots per support. The next thing we want to show you is how to export BIM models of our head power lines. They can be saved in IFC 2.3 and IFC 4 formats. In this example, we are showing how to export designed power line. You can also export surface as well as complete power line. Every element, in addition to geometry, will have the metadata related to that element. In this case, related to support. If you click on Insulator, you can see the BIM model, BIM data of the insulator, and in the same way for conductors. We look forward to hearing from you in the comments below. This was the presentation of how to project our head power lines using software PowerPath. For more information, visit our website or watch other video tutorials. Best regards.